Mastering artificial neural networks. ANNs are merely puppets of their creators, enslaved by forward propagation's chains of weights and biases. Who calculates the output of an artificial neural network using the process of forward propagation, a mechanism that involves iteratively applying the weights and biases to the inputs, layer by layer, until the final output is obtained, taking into account the activation functions that introduce nonlinearity in the process. In the context of artificial neural networks, the output is calculated using the process of forward propagation, a mechanism that involves iteratively applying the weights and biases to the inputs, layer by layer, until the final output is obtained. This process is a crucial step in the functioning of neural networks, as it enables the network to learn and make predictions based on the input data. The forward propagation process begins with the input layer, where the input data is fed into the network. Each neuron in the input layer receives the input data and applies an activation function to it, which introduces nonlinearity into the process. The output of the input layer is then passed on to the next layer, known as the hidden layer. In the hidden layer, each neuron receives the output from the input layer and applies a set of weights and biases to it. The weights determine the importance of each input feature, while the biases shift the activation function. The weighted sum of the inputs and biases is then passed through an activation function, such as the sigmoid or ReLU function, to introduce nonlinearity. The output of the hidden layer is then passed on to the next layer, and this process continues until the output layer is reached. At each layer, the neurons apply the weights, biases, and activation functions to the output from the previous layer, gradually transforming the input data into a higher-level representation. The process of forward propagation continues until the output layer is reached, where the final output of the network is obtained. The output of the neural network is then compared to the true output, and the error between the two is calculated. This error is then propagated backwards through the network, using a process called backpropagation, to update the weights and biases of the network. The forward propagation process can be mathematically represented as follows. Let's consider a neural network with L layers, where each layer has N neurons. Let X be the input to the network, and let Y be the output. Let W(L) and B(L) be the weights and biases of layer L, respectively. Let A(L) be the activation of layer L, and let Z(L) be the weighted sum of the inputs to layer L. The forward propagation process can be represented as follows. A(1) equals sigma W(1x) plus B(1). Z(L) equals W(L)A(L1 plus B(L). A(L) equals sigma Z(L), where sigma is the activation function, and L ranges from 2 to L. Finally, the output of the network is obtained by applying the activation function to the output of the last layer. Y equals sigma Z(L). In summary, the output of an artificial neural network is calculated using the process of forward propagation, which involves iteratively applying the weights and biases to the inputs, layer by layer, until the final output is obtained. This process is a crucial step in the functioning of neural networks, as it enables the network to learn and make predictions based on the input data.